Hi, my name is Firdaus, and for our fluid mechanics video assignment, we'll be focusing on the topic of properties of fluid, more specifically surface tension.
It's amazing how a simple cup of water can mean so much from a different perspective, particularly the different forces and fundamental principles of physics acting on it. From a certain point of view, you can receive heaps of knowledge by observing how fluids react to external forces, like tides in the ocean caused by the gravitational pull from the moon and the sun. The term fluid mechanics can be derived from two simpler meanings. Fluid means a substance that has no fixed shape like gas or liquid, and mechanics is defined as a branch of applied mathematics and physics that deals with motions and forces. The principles of fluid mechanics is inevitably applied in our daily lives, from taking a shower in a bathtub to huge and big reservoirs and dams. So, it's important to study and observe these phenomena. In this video, we'll be focusing on the properties of fluids, particularly surface tension.
The contents of this video are the objectives, the introduction of surface tension, the application of surface tension, the benefits of learning surface tension, and the conclusion.
The objective of this slide is we are going to understand about the principle of the surface tension and the benefits of this phenomenon and how does it able to help us in our real life.
Hi, my name is Jonas and I'm here to introduce to you what is surface tension. By definition, I believe surface tension is the tension of the surface film of a liquid caused by the attraction of the particles in the surface layer by the bulk of liquid, which tends to minimize surface area. Surface area is a phenomenon that occurs when the surface of a liquid is in contact with another phase, such as solids or gas, or could very well be liquid as well. During this phenomenon, the surface of the liquid behaves like an elastic sheet, as you can see at the back of this picture. Typically, surface tension is measured in dynes per centimeter. The force in dynes required to break a film length of a centimeter. The definition of surface tension enables us to understand that it primarily depends on the forces of attraction between the particles within the given liquid, simultaneously upon the object which it has contact with, let it be gas, solid, or even liquid. Here are two common cases where this phenomenon are showcased. For instance, the water strider and the floating needle. But today, we are going to look into something more interesting.
Now that we've known some theories of surface tension, let's look at its application. We're going to start with experiment 1, which is overflowing surface tension. Let's observe and investigate what was going on in the video shown before. Firstly, a cup of water contains water molecules. There are around 7.91 quadrillion or 7.91 times 10 to the power of 24 water molecules in a 230 gram cup of water. This shows how small water molecules are. Each water molecule is made up of one oxygen atom and two hydrogen atoms in a V shape. Water molecules tend to stick close to each other. This is due to a force called cohesive forces. Cohesion happens between all liquid molecules, but because the molecules in a cup of water pull each other equally in all directions, they tend to cancel out. However, since the surface of the water has air molecules above it instead of water molecules, at the surface, the cohesive bonds are much stronger than the ones inside the glass. These stronger surface bonds generate a net inward force pulling the surface molecules towards the middle of the glass that keeps them together. This strong inward force causes the molecules on the surface to contract and to resist being stretched. This in results creates an elastic tension at the surface of the water, also known as surface tension. For our second experiment, let's show something a bit more interesting, like surface tension propulsion. So, what happens when you add soap into water? Soap molecules consist of a charged polar head and a long non-polar tail. This polar head is positively charged and attracts a negatively charged oxygen atom in the water molecule. When soap is added into water, the water molecules will be attracted to the soap molecules. This causes the network of hydrogen bonds to be destroyed. The internal energy of the body of the water is reduced even further by surrounding the soap molecule head with the water molecules. This then kills the surface tension. By observing this video, we can see that there is a surface tension on the coin. A dome-like shape is formed by adding water onto it. Even when I try to move the dome with the Q-tip, the surface tension of water holds on quite well. Now, let's see what happens when I try to add a drop of soap water. It's observed that the water spreads out. This is because the surface tension in the water was destroyed by the soap molecules. Surface tension in water may be good at performing tricks such as being able to float a paperclip on its surface, but surface tension performs many more duties that are vitally important to the environment and people. For example, surface tension plays an important role in areas like the production industry of soap, detergents, and disinfectants. By studying and understanding surface tension, we have been able to take advantage of it to clean our clothes and disinfect bacteria. Surface tension plays a big role in soaps and detergents. By understanding how surface tension works, we have been able to produce soaps and detergents that effectively break the surface tension of water. This results in easier cleaning of our clothes with soap because the low surface tension of soap water readily soaks into pores and kills the bacteria. Similarly, surface tension is also applied in disinfectants. Usually, disinfectants contain solutions of low surface tension, like alcohol. The low surface tension allows the spreading of the fluid to spread out more effectively to the cell walls of bacteria and disrupt them. It's almost certain that surface tensions are a phenomena that affects our daily lives. We can find multitudes of examples where surface tension plays a role, like the classic example of a water strider walking on the surface of water. The high surface tension of water is also the reason why rain comes down as a spherical drop. High surface energy drives the water to drop to take a shape with the least surface area possible, making a sphere shape the most optimal. But why is surface tension all that important? Well, without surface tension, even the smallest particle would sink. This may cause failures in the ecosystem. Other than that, surface tension is also important in the research and development departments of products. For example, detergent formulas are optimized to improve their cleaning properties, paints are tailored to stick better on surfaces when they are applied to, and drugs are applied to improve their effectiveness. There are numerous other things that apply the principles of surface tension, and we even barely scratch the surface. But let's save that for another time. Other than that, thank you for watching, and until then, have a great day.